In this video, we will see about multi-level queue and multi-level feedback queue algorithms in CPU scheduling algorithms. First, we will see multi-level queue scheduling algorithm. Another class of scheduling algorithms has been created for situations in which processes are easily classified into different groups. For example, a common division is made between foreground processes, that is interactive processes, and background processes or batch processes. These two types of processes have different response time requirements and so might have different scheduling needs. In addition, foreground processes may have priority over background processes. A multi-level queue scheduling algorithm partitions the ready queue into several separate queues. The processes are permanently assigned to one queue, generally based on some property of the process, such as memory size, process priority, or process type. Each queue has its own scheduling algorithm. Here, let us consider an example of a multi-level queue scheduling algorithm with 5 queues: system processes, interactive processes, interactive editing processes, batch processes, and student processes. Here the highest priority process is system processes and the lowest priority process is student processes. Each queue has absolute priority over lower priority queues. No process in the batch queue, for example, could run unless the queues from system processes, interactive processes, and interactive editing processes were all empty. If an interactive editing process entered the ready queue while a batch process was running, then the batch process will be preempted. In a multi-level queue scheduling algorithm, processes are permanently assigned to a queue on entry to the system. Processes do not move between queues. This setup has the advantage of low scheduling overhead but the disadvantage of being inflexible. Multi-level feedback queue scheduling, however, allows a process to move between queues. The idea is to separate processes with different CPU burst characteristics. If a process uses too much CPU time, it will be moved to a lower priority queue. Similarly, a process that waits too long in a lower priority queue may be moved to a higher priority queue. This form of aging prevents starvation, where in multi-level queue scheduling algorithm, processes are assigned permanently, so it cannot move between queues, higher priority or lower priority queues. So lower priority queues may cause starvation. And here is an example here. In general, multi-level feedback queue scheduler is defined by the following parameters: the number of queues, the scheduling algorithm for each queue, the method used to determine when to upgrade a process to a higher priority queue, the method used to determine when to demote a process to a lower priority queue, the method used to determine which queue a process will enter when that process needs services. The definition of a multi-level feedback queue scheduler makes it the most general CPU scheduling algorithm. It can be configured to match a specific system under design. Unfortunately, it also requires some means of selecting values for all the parameters to define the best scheduler. Although a multi-level feedback queue is the most general scheme, it also the most complex. So the difference between multi-level and multi-level feedback queue scheduling algorithm: in multi-level scheduling algorithm, the queues are permanent. The processes cannot move between the queues. So the lower priority processes can feel starvation. In multi-level feedback queue scheduling, we can move the processes from lower priority to higher priority and also higher priority to lower priority. In that order, we can solve the starvation problem here. So that's it for the scheduling algorithms. We will see the next topic in the next video. Thank you.